Okay. So, Van, do you have any doubts regarding the previous classes? Any question that you want to discuss?
No.
Okay. So, can you tell me something about different types of forces?
Yeah. There's friction, magnetic, and gravity.
Okay. So, what are they?
There are different types of forces.
Tell me what is magnetic force. Tell me what is gravitational force.
Okay, friction force. Um, it can slow objects down. It can heat up objects, and it can cause wear and tear.
And can cause wear and tear. Very good. And then what else?
Magnetic force is caused by magnets, and gravitational force. It pulls objects to the Earth's core.
Okay. So, I've taught you different types of forces. I've taught you force is equals to mass into acceleration. Okay.
And gravity is 10 newtons.
Gravitational force also I've taught you. Okay. So in today's class, we'll be moving ahead with the next topic. Can you tell me just the name of the last topic? Just it was gravitational force only.
We were learning chapter 1, forces and motion.
I want you to know, tell me the last topic. I covered the types of forces, right? So what was the last topic that I made you write? The notes you might be having.
Calculating forces.
Okay, I taught you calculating forces, right? So look on the screen. So in today's class, I'll be teaching you one formula, that is force is equals to mass into acceleration. Now this is a very important formula. What happens is,
You taught me this last class.
yeah, I taught you, but I want to teach you the application of this. Now what happens, let's suppose this is an object. There is a force of 10 Newton acting on the right and force of 20 Newton acting on the left. The mass of the object is 10 grams, let's suppose. Okay. Now what will happen is, will the object move?
Yes.
Yes, the object will move. In which direction should the object move?
Left.
Left. And with what acceleration is the object moving? This is the direction of the motion of the object. But I don't know.
Acceleration will be 1 meter per second squared.
No, not one. This is the direction of the motion of the object, and this is the acceleration. So acceleration is also in the left direction only. Acceleration is also in the left direction only. Now what happens is, I have this formula, force is equals to mass into acceleration. So from here, I have the formula for acceleration also, that is F upon m. What is the force acting on the object? Force acting on the object will be 10 Newton, not 20. 10 Newton. Because 10 and 10 got balanced, so only 10 is remaining. Understood?
Yeah.
So, and then what is the mass? Mass is given 10 grams. You will convert 10 grams to how much?
0.001.
Yeah, so 10 and 10 cancelled. So acceleration is 1000 meters per second. Okay, this is a lot of acceleration. So what we can do is, we can take this, if I take this in kgs, so what will happen? This will be cancelled and then I will have 1 meter per second. Okay. Now, let's come to the next one.
Ma'am?
Yes.
Why are we timesing by 1000?
Because this is grams. And when mass is given to you in grams, you have to convert that into kgs. Okay.
But the SI unit of mass is grams, right?
In force, We are using kgs.
Oh, okay.
Shall we use mass?
Do I copy this down?
Yeah, just copy.
Ma'am, I have a question.
Yes.
So will mass equal force over volume, force over area, or
No, not
acceleration?
even. Mass.
Yeah,
Mass will
mass
equal
will
force
equal
by
force over acceleration.
over acceleration. Yes.
Oh, okay.
Now, next thing I have is just note this thing down, and also always remember SI unit is not grams, it's kgs only, not grams.
Oh, okay.
Now, then you have one more relationship, that is weight is equals to mass into gravitational acceleration due to gravity. Acceleration due to gravity, what happens is weight, I told you weight is a kind of mass, weight is a kind of force only. So weight will be equal to m into g. This also I taught you in the last class. Did I teach you
Yeah.
stopping distance?
Yes.
I taught you stopping distance. Okay. Did I teach you force acting on falling objects?
Air resistance.
No, falling distance. Yeah, I think I taught you terminal velocity.
I forgot about terminal velocity.
Do you have it written in your notes?
Yeah, I wrote it down.
You wrote it down? Okay, so I'll just start from there only. So now next stopping can be stopping distance. Can you explain me about stopping distance? I discussed in last class.
Okay. Stopping distance is the distance between thinking distance and when the object has zero
Braking
acceleration.
distance. So stopping distance is equals to thinking distance plus the braking distance, right?
Yeah.
Okay, now next thing is what are the forces acting on falling objects? What are the forces acting on falling objects? So when an object will fall, what do you have? It is first of all pulled down by gravity, and then also there is air resistance. So there are two forces. First of all, the force of by the gravity, and second is the air resistance, right? What does the air resistance do? Air resistance is always in the direction of motion or opposite to the direction of motion?
Opposite.
Opposite to the direction of the motion, exactly. So air resistance will act opposite. Okay, it will act opposite to the direction. Now, I also taught you as the speed increases, air resistance also increases. I made you write this point. Now, what is the terminal velocity? Terminal velocity, I told you when all the forces on the object is balanced and the object is
So
falling
it's
at
a constant speed.
that was terminal velocity. So these points were completed. Now, then in your syllabus, you have a practical, extension, and force. So they are telling you that whenever force is applied to stretch a spring or rubber band, what happens? Let's suppose this is a rubber band or this is a string, and then force is applied on both of its ends. So what will happen? It will extend. After application of force on this end also I am applying force, this end also I am applying force, so it extends, right?
Yeah.
What happens? So the extension increases with force. So when you will put more force, your extension will also increase. When you will put less force, then extension will decrease. Okay.
Yes.
Then next you can write example can be rubber bands. Then it can be metal wire, etc. Okay. Next is Hooke's law. Now, what does the Hooke's law tells you? Hooke's law is basically telling you that whenever you are applying force to any object, it extends. So they are telling you force is directly proportional to extension. Force is directly proportional to extension. Right? Now what happens is F is equals to K X. What is this formula now? Very important formula. F is the force. K is the spring constant. X is the extension in meters. Okay. Oops. Got it? Now what
Okay.
happens is, so always there is a linear graph like this. If you plot a graph between force and length, it is a linear graph. But what happens once the elastic limit is reached for any object? That means it has stretched to its maximum. After that, the graph is not linear. After that, even on a small application of force, a lot of extension will happen. Okay? So that is elastic limit of that. Just 1 second. By the time, please write.
Ma'am, can you please scroll down? Can you please scroll a bit higher? Ma'am, can you please scroll down? Ma'am, what does K stand for in the equation?
Yes, Vivan.
What does K stand for in the
K
equation?
stands for spring constant. Okay.
Okay, thank you. I'm done.
Yes, Vivan. Just give me a minute, okay? Then we'll continue. You can revise by the time.
Okay.
Yes, Vivan. Am I audible?
Yes, ma'am.
Yeah. Please tell me, did you understand? Any doubts do you have up till now?
No doubts.
Okay. Now, next is elastic behavior. what happens is, what is the elastic behavior? So any material or a material shows elastic behavior if it returns to, very important point, just understand very carefully and read while I'm writing. It returns to original shape and size once force is removed. Now, what is the meaning of elasticity? That when elasticity, students are often confused with elasticity and stretching as the same thing. Stretching and elastic behavior is not same. An object can be stretched but might not be elastic. Okay, what is the meaning of elasticity? That whenever you are stretching any object, and see, for stretching you are applying force, but whenever you are releasing the force, the object returns back to its position. Okay, it returns back to its position. That is called elastic behavior. For example, clay. You can stretch clay, but does it return back to its position once force is removed?
No.
No. A rubber band. You can stretch a rubber band also. So clays can also be stretched, rubber band can also be stretched. But which is elastic? Which is elastic? Rubber band is elastic, right?
So, ma'am, elasticity is when an object can be stretched and then it can like go back into its original shape.
Yes. Now next is example is a spring returns to normal length after stretching, right? Okay. Now next we come to the further topics, that is momentum, mass and velocity. So what is momentum? If you have to define momentum, momentum is denoted by P. So let's suppose there is an object. This object has some mass m and it is moving with some velocity v. So what is momentum? When you multiply the mass and velocity of this object, it will give you its momentum. So momentum is basically the product of mass and velocity of any object, right?
Yeah.
So if I have
But
to define
what
motion,
does momentum do?
yeah, exactly. So momentum is basically helping us to measure the quantity of motion of a moving object. It measures the quantity of a moving object. Now next is, now what happens? Greater is the mass or velocity, greater the momentum. Okay, just remember these points. Now next is, there can be one more formula for force. One of the formula for force is F is equals to m into A. Another formula of force can be force is equals to the change in momentum divided by the time. Force is the change in momentum divided by the time. Understood? Now,
Yes, ma'am.
so what happens? Okay, do one thing. Just first note this much down and then I'll explain you further points.
Okay, ma'am.
Tell me when you're done. Okay, I will scroll.
Can you please scroll down? Ma'am, can you please? Okay. Ma'am?
Yes, Shivan. Completed?
Yeah. What is the SI unit of momentum?
I'll teach you that. I'll teach you. But first, tell me, did you understand till here?
Yeah.
Yeah. So I first have to discuss with the change in momentum with respect to time gives you force. Now, what happens, Vivan, over here is I am telling you that, okay, before this, I can tell you the SI unit. Okay, otherwise it will be left. Look here. What is the unit of mass? Kgs?
Grams.
No, kgs. I just told you previously also.
Okay.
The SI unit is kgs. And what is the SI unit for velocity?
Meters divided
Meters.
by second square.
Meters per second. So it is kg meter per second. Is the SI unit of momentum.
Oh, okay.
Now, I am telling you, force is the change in momentum with respect to time. That means if this is an object, it has mass m. It is traveling with a velocity of u. After some time, mass will be same only. It will travel with velocity v, right? So what is the momentum over here? mu. What is the momentum over here? mv. What is the change in momentum? P final minus P initial. So mv minus mu. So it is mv minus u, right?
I don't understand.
1 second. Yes, Yvonne. Yvonne, put on your camera. See, what happens is this is an object. Okay, it has some mass m. This is the velocity with which it was traveling. So this is initial velocity. Now the velocity changed. Mass will
Yeah.
remain m only, and the final velocity is v. What is the formula for momentum? Mass into velocity. So the initial momentum will be mass into initial velocity. Final momentum will be mass into final velocity. What is the change in momentum? What is the change in momentum?
I don't know.
Oh, change in momentum is final minus initial. That is only the change. What is the final velocity? mv minus mu. So m v minus u. Understood? M comes out from.
Oh, okay.
So that becomes the. Now if you put the change in momentum in this formula, what does it become? We know force is equals to change in momentum. So m v minus u upon time. So this can be another formula for force. Okay. This is another formula for force. Okay, what happens is, now let's suppose Vivan try to find out the look here, I'll give you time, right? If I try to find the relationship between force and time. So if the time decreases, the force increases.
Yeah.
Force and time are inversely proportional. So one, if time increases, force decreases. So if I want in certain situations the force to be less, so I need to increase the time. I
Yeah.
need to increase the time. So what can be the example for this? Whenever you are catching a ball, what do? You catch a ball and bring your hand backwards. What does the cricketers do? The bowlers, what do? Is they catch a ball and they bring the hand down. Why? Because the ball is moving with a very high velocity. It has a very high velocity. So it can cause harm in their hands because it will apply a very high force. So they want to reduce the time in which the ball is stopping. Okay, that is why they bring their hand also in motion, so it moves along with the ball and slowly the ball is coming to rest. The ball is not coming to rest instantly, but the ball is coming to rest in.
So the time increases.
Understood?
Yeah.
Yes. Okay, so note down these things. written this part? Tell me, everyone, have you written this part?
Not completely.
Just tell me when you're done, okay, everyone?
I'm done.
Okay, everyone. Now we come to the next topic, that is law of conservation of momentum. Law of conservation of momentum. What does the law of conservation of momentum tell you? It basically tells you that when two objects collide or bounce off, their total momentum remains the same. What does this mean now, Ivan? What do you understand by this line? What do you understand by this line? For example, there is an object moving in this direction. There is an object, another object. This has mass m1, this has mass m2. And they collide. They collide. Okay. What will happen once they collide? Their momentum will remain the same. When they collide, see, they might be moving in different directions with a different velocity. So this is u1, this is u2. So let's suppose after colliding, this object goes over here and this object goes over here. This is m1, this is m2, this is v1 and this is v2. What is this m1, v1? First of all, u1 and u2 are initial velocity. v1 and v2 are final velocities. Okay?
Yeah.
Now we want to see. This is m1 mass. This is another object. This is m2 mass. This is initial velocity with which it was moving. This is final velocity, initial velocity of m2 object with which it was. They collided. Once they collided, they are now moving in different directions, right? So this is m1, this is m2, this is v1, this is v2. v1 is the final velocity of first object, v2 is the final velocity of second object. Do you understand this question?
Yeah.
Now they are telling you total momentum remains the same. Total momentum remains the same. What is the meaning of total momentum? What is the total momentum over here? m1 u1 plus m2 u2. What is the total momentum over here? m1 v1 is equals to m2 v2. They are telling you now this, sorry, plus, not equal. Now they are telling you that this quantity and this quantity is equal. So this is what law of conservation of mass is. m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2.
Oh.
Understood? This is a very important theorem.
But ma'am, can't the m's cancel out?
No, m's are not same. Here it is m1, here it is m2. So you cannot take out common. Something can be cancelled only when it can be taken out as common. Okay?
Okay.
Just do this law of conservation of momentum. Note
But
it down.
ma'am, there are two m1s and there are also two m2s.
But they are on either side. Okay, see, if you want to take, with which you want to cancel? You want to cancel this M2 with this M2? Tell me.
Yes,
You want
ma'am.
it? But Vivan, I told you before that in any equation, I cannot cancel a number if it is being added or subtracted with another number. Here, M2 is being added with this number. So you cannot cancel it. Okay?
Okay.
So you cannot cancel. Note down this question.
Also, ma'am, when are we going to finish this chapter?
I think in 2 more classes we would need.
Okay. So after this chapter, can we start chapter 4?
Yeah, sure. Do you have any test schedule?
No, but in school we're learning chapter 4 now, that's why.
Okay, sure. I'll quickly complete this chapter and then move to chapter 4.
Okay.
Yes, Shivan, did you note it down?
Not yet. Ma'am,
Yes, Shivan.
what is the name of the formula at the bottom?
It's just law of conservation of mass.
Okay.
Noted?
Yeah.
Okay, woman. So for today, we'll just keep it up to here only. Right? I hope you understood everything.